Hi guys. A couple of you were asking about this question here from the homework on, I think it was, let me just check here, homework tab. It was question 10C. So when did I give that? That was Tuesday's homework, question 10C there, paper 2, 2018. Okay, so I am talking about this one. Okay, so a couple of you are asking about that. So I'm going to do a quick video just to further explain the solution, okay? Because this is going to happen, quite a bit. Like where sometimes the written solutions are good enough and you understand it, but sometimes you need a video explanation as well. Even then it can be still very difficult. But anyway, it gives you a better chance. Now let's have a look at this. The diagrams below show Cameron's ladder. So this is 2018, paper 2, question 10, part C. He has the ladder there up against the wall, okay? Both of these ladders make the same angle with the horizontal ground. What they mean by that is that this angle and this angle is the same, okay? And of course, this bit here and that bit there, they're both 90 degrees as well, okay? Now, use similar triangles. So if you were to go to your book, this is what you need to look for in the index page. Okay, similar triangles. If you want to go back and revise this to find the value of x, the vertical height of Jamie's ladder. When we were doing this in school, I would have introduced it by telling you that we can get the height of the spire or something that's really, in Dublin, in the city centre, or something really tall building by using this similar triangles. Okay, so Cameron's ladder, Jamie's ladder there, and they give us some dimensions. Okay, now these, first of all, what are similar triangles? Similar triangles are triangles that have the same angles, okay? The same angles, and we're told, as we've talked about already, we've been told that this angle and this angle are the same. That angle there in the corner, they're both 90 degrees, okay? So if two of the angles are the same, then the third one is the same as well. So similar triangles are triangles where the three angles are the same in both, okay? Now, they can be different size triangles, okay? They're not identical triangles, they're not congruent triangles, but they're similar because their angles are all the same. And we have a couple of theorems that come from that. And one is that that in these two triangles, that their sides are they're proportionate in size. So if I just go over maybe to the right hand side here a little bit, and I just do a more simple kind of question, like just put in more easy numbers. Okay. So it's always nice. It's always a good way to explain something by using easier numbers, So let's say we've two triangles here, they're similar, let's say, okay? And we'll say that this here is a size of 5, and that this here is a size of, let's say, 4, okay? Then let's say that this is 15, okay? And we're looking for this. So it's very similar to that question there, very similar, okay? Except I've given nicer kind of I've given nicer diagrams and nicer numbers. Now, these two triangles are similar, and I'm telling you that the sides are proportionate in size. So that means if we look at this here, this side here, okay, that corresponds to this side. So they're what we call corresponding sides, okay? Have a look at the 5 there and the 15. What would you multiply the 5 by to get 15? Okay, so 5 into 15 goes 3 times, so you'd multiply by 3, okay? Now, you'd multiply by 3. That means, because they're similar triangles, that means that the same applies to this side and its corresponding side, okay? So this side and its corresponding side. So we'd multiply the 4 by 3, which would give us 4 by 3, 12. And that's x, all right? So that worked out, those numbers are a little bit nicer than these ones over here, okay? So we have to figure out, I suppose, let's erase what I've done here. I've done it very mathematically. I've done it very algebraically. Perhaps I'll just do it as a little different this time. I'll do it the same way I did the last one. So we're looking here at the, let's use the same colors actually, as I used over here. Look at that 6 there, that's 6, okay? And here is 9, all right? What would we multiply 6 by to get 9? Okay, not as easy this time as the 5. What would we multiply 5 by to get 15? If you know your times tables, you know that's 3. So what would we multiply 6 by to get 9? Well, just simply divide 9 by 6. 9 divided by 6 is 1.5. Okay, so you'd multiply the 6 multiplied by 1.5 gives you 9. Okay, now let's use that 1.5 to get this. Okay, so this side corresponds here to this. So what? Let's multiply by 1.5. So grab your calculator, and it's 5.8 multiply by 1.5, and that gives us 8.7. 8.7. That is what x is. Now I'll just do it down here the way I did it, the way I would have done it in class. I hope that you understand that. If you're not, just rewind the class. So to get to write this so that's x so to its corresponding side 6. Now multiply, we want to get x on its own, so we multiply both sides by 5.8. And if you do this calculation, grab your calculators there now, and if you do this calculation, 5.8 bracket, use the fraction button, 9 over 6, close the bracket, press equals, you get the same answer, 8.7. Same answer as we got up here. Okay. 2 ways how to do it. You choose which way you want to do it. Okay, no problem. Tricky question, but where you'd look for, if you want to do more questions like this, find similar triangles in your book. I don't have the book with me, so I'm not too sure what page that's on. If you can't find that, please let me know, and I will find the page number and get back to you. Okay. Best way to get back to me is emails. Okay. Thanks, guys. Hope that helped.